Hello everyone, welcome to today's live session. I hope I'm audible. Can anyone confirm that once? If you can hear me and you can see me. Any one of you, just once. You can just type in the chat box and confirm if you can hear me. Okay, thank you so much. Uh, and once if you could confirm that you can see my screen. Can you all see my screen? Okay, great. So, welcome all to today's session, today's live session for the subject Strategies for Sustainable Design. Uh, the course instructor for this subject is Professor Shivaji from IIT Hyderabad, and I am the teaching assistant. I am Nikita Ranjan. I am a PhD scholar at IIT Roorkee, and I'll be taking the live sessions for this subject. So the live sessions for this subject are meant to act as doubt clearing sessions. So you are assigned weekly assignments, and similar to the weekly assignments, we'll have weekly live sessions in which I'll talk about the week's lectures, a little bit about the week's lectures, and if you have any doubts regarding the lectures, we can go over that. Apart from that, I'll also discuss questions which were assigned in the previous runs of the weekly assignments. So I'll go over those questions and I can solve them for you so that you have an idea of how to go about solving your own questions. So one major clarification here, I would not be solving the questions that you are presently assigned that you have to solve for yourself, because you are going to be graded on those. What I will be solving are the questions which were assigned for this same subject in the previous runs of this subject. So what that will help, how that will help is that I can, in the case of subjective type questions, I can give you a rundown of all the background material which for the questions that are assigned, and I can help you figure out the approach of how to solve the questions, what background material you need or for which kind of questions, and how to go about solving them, the questions. And for numerical questions, I'll show you how to solve specific numerical questions which were assigned. So it will be a different example from the question which you are currently assigned. So from the example, you will learn how to go about solving the question, and then you can solve the assigned question for your own. I have a very sincere request to all of you that please do not ask the questions which are assigned in the current run, as I am not supposed to be solving them. If you have any doubts in the background material related to that questions, I can help you with that. However, I am not supposed to answer your current assignments. Uh, Also, because the assignments which we are going to solve today for week 1, they are subjective type questions, and many of the questions are quite similar to the ones which are assigned currently. So what we'll be doing is, I won't tell you the answers for the questions, but I'll tell you the background material, and I'll tell you how to approach the questions and how possibly you can arrive to the correct answer. So that is how we'll go about. Also, all the sessions, all the live sessions will be recorded. Uh, all the live sessions will be recorded and they will be made available for you to access. So there will YouTube links for the recorded sessions will be shared with you so that you can peruse them at your own time. Also, a copy of all the material which I present here in the form of PPT or other supplementary material which I'll be providing. Everything will be made available to you as well. A link to a drive folder will be shared with you where all the materials, where you will be able to access all the material. Okay, and even if you miss some of the sessions, you can go and access the material as well as the recording of the session. Uh, Recording of the session later as well. Also, apart from that, you always have access to the forum. So even after the live session, if you have further doubts, you can go to the forum and ask your questions. Your questions will be answered there as well. They could be attended either by me or Professor Shivaji. So either one of us can get to your questions. So even if you miss some of these sessions, no need to worry about it. You can go to the forum and ask the question, or you can even ask the question in next round. So these the way we are trying to help you is not just for the current assignments, but even for the exam which you'll write later. So I hope all this is clear to you. I have not given you permission to unmute yourself so that there are not much disturbances uh, throughout the session. However, you can type your questions in the chat box and I'll get to your questions if anyone has any questions apart from what I'm explaining. So let's start. Today we'll be going over week 1. These are the lectures which you covered in week 1. So first would have been the introductory lecture on strategies for sustainable design, which is the subject. And after in the introduction, you would have gotten to know a little bit about what you can expect from this course, what the course structure will be, what you'll be getting out of it, and also you would have covered an introductory session on sustainability, of what sustainability is, how it can be defined. Uh, so that would have been your lecture 1. Then the next lecture was perspectives around sustainability. So in this you would have studied different perspectives surrounding sustainability, how various scholars have uh, defined, not only defined, but okay, so how various scholars have defined sustainability, what is their approach of looking at it, and apart from scholars, then there are different streams of thought, different ways of how sustainability can be perceived by economists in terms of environmental sustainability, in terms of social sustainability, all of those things, and then also intersections of various thoughts. And then the last lecture you would have covered would be spheres of energy efficient, different spheres of energy efficient, green, environmental, and sustainable designs. So there is a lot of misconception usually surrounding all of these words like energy efficient or green or environmentally sustainable or sustainable. So this lecture actually explains to you in very detail, clarifies how all of these terms are different from each other, what each of them means, and how to use them in studying sustainable design. Okay, so we'll move on to the questions now. So first question. Sustainable is conserving an ecological balance by avoiding dash of natural resources. So it is a fill in the blanks type of question, and you are supposed to fill in the blank provided uh, fill in the blank using one of the four options which are provided. So the options are augmentation, depletion, agglomeration, and dispersion. So I hope all of you know the meaning of all four words, and you know what it means. How you should approach this question is you should go back to how sustainability has been defined, because this question focuses on the definition of what sustainable means. So you would have studied various definitions of sustainability. For example, the first very basic definition of sustainability is the one which comes from the dictionary. So sustainability is an adjective which means able to be maintained at a certain rate or level. For example, sustainable fusion reaction. So it can be maintained at a certain level and it will keep on going on the same level. Or another example can be uh, conserving ecological balance by avoiding depletion of natural resources. So these are two examples of what sustainability can mean. So this is one definition of sustainability. Uh, Another definition of sustainability you might have studied was Brundtland's definition. So this definition comes from the Brundtland Commission. So the Brundtland Commission published a report in 1987, which is called Our Common Future. So it was the chairperson of this commission was Gro Harlem Brundtland. So owing to her, this report is also known as Brundtland Commission or Our Common Future, as I just said. So this was a seminal report because for the first time in this report, there was an acknowledgement of how sustainable development is essential and it cannot be separate uh, from other economic development, which governments then saw. So governments then saw economic development as separate from sustainable development. So our environmental needs or environmental protection came as a separate topic from economic development or other facets of development of the country. However, after the Brundtland Commission came out with the report, Our Common Future, for the first time, general development or general economic development of any country or economic development on the global platform was started to be seen as a part and parcel of economic development, and it was acknowledged that to ensure that the economic development can be sustained, we need different practices. So from that, the term sustainable development came about. So in that report, uh, Brundtland gave a definition of sustainable development. So that is a seminal definition of sustainable development. It says uh, sustainable means to make development sustainable, to ensure that it meets the needs of present without compromising the ability of future generations to meet their own needs. So I have also shared a link to websites which you can access if you want to go through uh, this document. Uh, so uh, this is the link to uh, the website. So as you know, earlier when the report was published, uh, The commission which published this report was known as the Commission on Economic World Commission on Environment and Development. However, that has been discontinued now, and all of this has been consolidated under United Nations Sustainable Development Goals. So that is why this is an old website, which but this website still has the PDF of our common future, which was published then. That is why I've shared this with you. So you can go to the links that will be provided to you in the PPT, and you can go through the document for yourself. I'll just share an overview of the document with you. I hope it is visible to all of you. If it's not visible, please put a message in the chat box so that I can make some adjustments. So sorry, this is taking quite a while. We'll go to the other website till then. So I've also shared the website, the new website for this. So this is, as I said, that all of this has been consolidated under Sustainable Development Goals, and now we started with our common future report. However, everything has been consolidated under the 17 sustainable development goals which we have right now, and we'll discuss about these SDGs a little bit later on in the presentation. So PDF is taking a while. We can come back to that later. But I've shared this document with you, so you can go over it on your own time as well. Apart from that, another definition which you would have studied is D.K. Ching's definition, which says that sustainability depends on local and external contexts, and is also necessary for building design process, and without the local and external context, one cannot proceed further with the sustainability. So it is another very important component of sustainability. So sustainability you cannot perceive or understand independent of its context. So if one sustainable practice can be sustainable in one area or one region, but it's not necessary that the same practice will be sustainable in another region. So an example of that would be vernacular architecture, if you've heard of it. So vernacular architecture is actually the indigenous architectural practices uh, which are carried out by in people of a particular location based on the climate and the needs of the people of that area. So usually what vernacular architecture does is it uses the materials, resources and techniques which suits the location in which it is set. The same materials and building techniques would not be sustainable for another region. For example, I can tell you about Bhunga houses. So you might have heard of it. Bhunga houses are houses which are built in the deserts of Rajasthan by the locals, and they have a circular plan, and they have very small openings, and the main goal, and they have very thick walls covered with mud. So a lot one very key goal in building bunga houses is that minimum minimum sunlight or minimum heat from outside the built environment enters inside the building. And then it is again built using the local materials, which is the cow, the cow dung or the waste from animals, mud, and other locally available grass and other materials. So, if the same house uh, was built in an environment which is very humid and uh, is hot and humid kind of climate, it won't work there. First of all, because if you have very small fenestrations or very small openings, you will have a lot of need for artificial ventilation inside the building, and then that would add to your energy needs which are needed in the building. So this is just one example which tells you how sustainability is local and external context specific. So you can't take a sustainable practice from one area and put it into another area and still call it sustainable. I hope that is clear. Uh, Another thing which you would have studies was defining sustainability in terms of a formula. So if you see sustainability as a formula, so it can be seen as consumption is should always be for something to be sustainable, or for an area to be sustainable, or practices of resource consumption to be sustainable. Consumption should always be less than regeneration plus restoration. So what regeneration means is whatever resource you are consuming, it gets regenerated over time by natural processes, or it gets restored by human intervention. So the amount that you consume should always be less than the amount that is regenerated by nature itself, or the amount that is restored by uh, ways of human intervention. So, for example, very good example for this is use of water resources. So, the amount of water which you are consuming in an area should always be less than the amount of water which through natural water cycle processes it comes back potable water. Consider potable water, not just any water. Consider potable water. So the amount of potable water which you consume should be always less uh, than the amount which gets regenerated through the natural processes of water cycle, and then again the amount that you restore from maybe practices like rainwater harvesting or wastewater treatment or things like that. So I hope that makes it a little clear. So going back to the question, uh, I hope it is clear now. Uh, Among the four options, what would be correct to fill in the blanks? Sustainable is conserving an ecological balance by avoiding dash of natural resources. I hope it's clear to you. Moving on to the next question. So the next question is, the three aspects of sustainability are social, environmental, and dash. Okay, you do not have to say the answers. I'll be going over them. So you are given four choices: economic, material, psychological, and architecture. So you would have studied this Venn diagram in your lecture. So this is called the sustainability paradigm, and this shows that sustainability is not just environmental sustainability as is perceived by a lot of people. So sustainability can be studied in various dimensions, and the three key dimensions which are considered by a lot of scholars and uh, researchers who study sustainability are economic, social, and environmental. However, there are even intersections between the different dimensions, and even the intersections of the various dimensions can be their own fields. So, but largely the three dimensions which are associated with sustainability are the social, economic, and environmental sustainability. So, what social means is sustainability in terms of standard of living, education, community, and equal opportunity to all. So, for example, you cannot call a practice sustainable if the practice prevents a large section or even a small section of society from accessing the benefits which is generated from the practice. So, for example, imagine that uh, imagine having open urban green spaces in a city, and imagine that only some part of the population can access it and other part of the population cannot. So there might not be any visible uh, downsides of it in the beginning, but with time you can see the population which is not able to access a resource. They suffer the downsides of not being able to access the resource. For example, if the green space is urban green space is a source of food production, so the population which is not able to access loses one source of food production. If it's a source for uh, uh, imagine purification of air or other ecosystem services, so the population, or even things like tackling urban heat island effect, so the population which cannot access the urban green space, which is not in close proximity to the urban space, or which doesn't have access to go use the urban green space, is devoid of the benefits which the other population is enjoying. So over time there can be conflicts, or even if there are no conflicts, the population which is not being able to enjoy it will suffer the consequences of not having that opportunity. So in that way, that practice is not sustainable. Similarly, environmental, I think most people know various examples of environmental sustainability. For example, use of any natural resource, just as I shared the example of using potable water. So, environmental sustainability uh, many a times studied as sustainable consumption and management of a natural resource. So using a natural resource in a way so that over time the way the resource is being used can be sustained, not only just for the human use but even for the use of other members of the ecosystem. It can be birds, plants, animals, so all part of the biodiversity. And then there is economic sustainability. So while social and environmental sustainability is essential, there also needs to be economic sustainability. So for example, if we just decide that we are not going to use natural resources anymore because we are depleting them at a very fast rate and there is not enough for everyone, or things like that. But if we do not generate economic output, we cannot sustain the society which is living off of the resources. So for that, for a society to sustain, the society needs to produce some economic output, so that people can have access to resources, people can have employment, all such things. So we can't just say that we are just to prevent degradation of some natural resources, or to just consider environmental or social sustainability and not consider economic sustainability at all. So if you are able to achieve uh, practices which cater to all the three dimensions, which take care of social, environmental, as well as economic sustainability, that practice can be understood as a very sustainable practice. I hope it is clear to you. So, going back to the question, I hope it is clear to you what the three aspects of sustainability are. Coming down to the next question. The country with most significant ecological footprint on the planet is dash. So you have four options: USA, Brazil, India, and Qatar. So what I'll tell you in this question is what ecological footprint is. So to understand ecological footprint, first you need to understand material cycles. So there are two kinds of material cycles. One you can call a linear cycle, or another is a closed cycle. So linear cycle can even be understood as an open cycle, and uh, then we have a closed cycle. So linear cycle functions like: you extract some raw material from nature, you produce something out of it. It can be a product, it can be a service, and then there is packaging and distribution. So if it's a product, there is packaging of the product for distribution, or it's a service, it's just distribution. So then there's distribution, then you use the product, or and maintain it for its life cycle, and then you dispose it, or incineration is one example in the case of waste which is not usable. Closed cycle is something closed cycle is something like: you first extract raw materials, then you produce something out of it, product or a service. You then package it for distribution, and then use it, maintain it for its life cycle, and after that you reuse or recycle the end product at the end of its life cycle. So this is referred to as a closed cycle. So in this you can see whatever raw material you extracted from the nature, it is not for example, at the end of linear cycle, it is just going to waste, either disposal or incineration of the end product. You cannot reuse it again. While in a closed cycle, uh, at the end of the life cycle of the product, you can again reuse it uh, for some other purpose, or just recycle the raw materials from the product, and then use that raw material in production of either a similar product or service, or a different product or service. However, uh, this is a very simple representation of what product cycles are. Product cycles actually are not so simple, and they take complex forms in their production, use, and then disposal, or to use recycle method. So this is another example of a project cycle given by UNEP's life cycle initiative. So this is how in practicality most of the time a project's life cycle looks like. So you extract raw material, you design and produce something, there is packaging and distribution of the product, and then you use it, maintain it over its life cycle, and then several things can happen. either it can go to disposal. So for disposal, it can go to a landfill as a waste product, or it, even from the landfill, it can be incinerated. So in many cases, even incineration is a method considered as a method of recovery, because many a times uh, energy generated from the incineration is considered as uh, uh, one product which is obtained out of the incineration. Or another way it can take is that after you've disposed it, uh, you or someone else can use it for another purpose, and then it goes back to the use and maintenance cycle, from where it is going to go again to the disposal. Or what you can do is recycle the material. So after recycling, you get raw material out of it, which raw material again can be then used for design and production of another material, which again then go through the cycle of distribution, use, and disposal. Or from disposal, you can recover some raw materials. You can extract, not from the whole product, you can't extract maybe not all of it, but some of it can be extracted as raw materials and can be used with the other natural resources, and then can go again in the cycle. So I have also provided the link to UNEP's website. So this is UNEP's life cycle initiative. So it focuses on the specific life cycle thinking, they call it. So how different projects go, how you can think about the life cycle of different products, and how what kind of practices can be used so that there is more sustainability, there is more reuse and recycle of the, the raw materials or the natural resources that we are using, and we don't follow the linear path of product use and disposal anymore, so that more of the products and raw materials that we use is recycled and used, and follows the cyclic type of life cycle. So you can see, you can go to further reading, study more. They have several other publications related to it, like uh, life cycle thinking in Latin America, greening the economy through life cycle management, and then how businesses can adopt life cycle management in their business practices. Then how the life cycle approach can be adopted into practice and all of that. They also have very specific concept related to life cycle approaches, like for example, corporate, environmental, and social responsibility. So you might have heard of this, that a lot of corporate bodies which produce plastic waste, like their products produce plastic waste, they now have this obligation that they are supposed to recycle uh, the plastic waste produced from their product. That is one example of corporate social responsibility. Then there are several other things of life cycle management, like what life cycle thinking is, what are the various systems and procedures uh, which go with life cycle management. And then there are several tools and techniques which can be used by practitioners, which can be used by you even to study and evaluate or assess if some practice is sustainable or not. Does it follow the uh, uh, life cycle thinking or not? So there are several tools like life cycle assessment, life cycle costing, cost benefit analysis, and all of that. So you can go further and go to this website and see for yourself. Oh, I'm sorry. I think it was not visible to you. I'm so sorry. Uh, So this is the link which I've provided, and this is the website. So this is what it looks like, and then these are the other publications which I was talking about. You can go through them, and then you can further read on life cycle approaches from here. This I just shared with you: life cycle management, corporate social responsibility, life cycle thinking, different systems and procedures, the various tools and techniques which are there. So I hope you give that a read. Okay, so moving on to the next slide. Okay, so what we were going on about here is ecological footprint. So you got from here uh, what sort of a cycle a product follows. So whenever we use natural resources from an area, we take something from an area, and we use uh, we use some amount from the biocapacity of that area. So to understand ecological footprint, you need to understand two specific terminologies. One is bioproductivity, and the other is biocapacity. So what bioproductivity is, it's the amount and rate of production which occurs in a given ecosystem over a given period of time. And the amount of biological materials that an area can generate, that is useful to humans in that given area. That is what is referred to as bioproductivity. Uh, what biocapacity is, the area which we are talking about, multiplied by the bioproductivity of that area, that is the biocapacity. So what biocapacity actually represents is the ability of that area, or in this case we are talking about the world, so ability of the world to regenerate the resources, uh, uh, to regenerate resources absorbed waste in a limited time period. So it represents the aggregate of production of various ecosystems which are present in that area. For example, arable land, pastures, forests, and then also productive water bodies like sea, lakes, and other things. So all of the resources which the area can produce uh, out of its different ecosystems uh, into that area, that is what biocapacity is. Some of that production can even come from built up or degraded land, so it might not be as much as a highly productive ecosystem, but still even a built up or degraded land can produce certain functions, ecosystem functions, or resources. So the larger the biological productive area is, the more biocapacity the earth has, or the larger the bioproductivity of the area is, the larger biocapacity the earth has. So either the area or the bioproductivity is increased, the more biocapacity we'll have. Uh, and then ecological footprint is actually then uh, it is expressed as the consumption of all the renewable resources in that area with a certain bioproductivity and a certain biocapacity in that area. The all the consumption that is done uh, by us uh, in by using various renewable resources like crops. So whatever we take for food, animal products, timber, even energy consumption, and even the land we use for building our habitats and everything, all of that in standardized units, which is GHA. So that is what ecological footprint is. It's a measure of how much biologically productive land and sea an individual population or any activity requires to produce the renewable resources that it consumes and to absorb the waste that is produced by either that individual or whole population, or if we are talking about a particular activity. So it is a multiplication of the population which is in that area. So it can be an individual or it can be a whole population if we are talking about the ecological footprint of a country, or it can be the population which is associated with a particular activity if we are talking about the ecological footprint of a particular activity, and then multiplied by consumption per person. So if we are talking about people, so however many people is there, so how that is population, however many people are there, and the amount of consumption one person does is that, and then uh, resource use intensity. So with how much intensity the population or the individual is using any resource, and then resource use inefficiency. So with how much inefficiency the resource is used. So multiplication of all of this is equal to the ecological footprint. If you want to know a little bit more about the ecological footprint, you can go to the EU's working paper on ecological footprint and biocapacity. So I hope you can see. Uh, this is the paper, and I've shared the link for this paper with you. So you can read the fundamentals of what ecological footprint is and everything, and then you can even see how the accounting of ecological footprint and biocapacity is done. So there are various methods in which uh, the aggregate of all the resources and functions an area can produce, that is aggregated, and that is explained a little in detail in this, and then how the ecological footprint or ecological footprint is accounted for, that you can see here, and then you can even see how it is applied on the calculation of ecological footprint for various countries or various population and everything. So you can see all of that in this paper. Hope that is clear. So another source which could be beneficial for you is the Ecological Footprint Atlas from 2008. So this I think also has been shared with you. Some parts of it have been shared with you in the lecture. So what this Ecological Footprint Atlas does is it provides a uh, various visuals and metrics of how what the ecological footprint of various countries around the world is like, what is the impact and footprint different countries have, not only countries, even what different types of activities. As I said, ecological footprint can be calculated for various activities also. So the major activities which are taking up the most of the resources, that also have been shared in this document. So you can also get to see their metrics, how they have calculated. Okay, so if you go to the appendix, you can see per person ecological footprint production and everything, how they've done it, how they've calculated, and things. And then let's go. So you can even see how the historical account of what the historical account of ecological footprint is, how it has throughout history, how different scholars have evolved the concept, and how it has evolved and what concepts we are using now. This is one example of a formula uh, which is available. So you can see this as well. What we are going to see here is this. So this is the humanity's ecological footprint which they have evaluated. So these are the as I told you, ecological footprint can be calculated for various activities as well. So the footprint we have generated because of using resources for built up land, which is there for forest land, cropland, which is used as fishing ground, grazing land, all of that has been calculated here. And then what our question comes down to, so ecological footprint generated by each nation. So this graph actually gives you an account of the largest uh, ecological footprint generators, the largest countries which uh, contribute to the ecological footprint, and their contribution to it. So as you can see, the largest area taken up by this graph, uh, taken up in this graph is by the United States of America. So I think you get the answer of your question now. So United States of America is the largest, is the country which with the largest ecological footprint. Then you can see the next is China, then India, uh, then uh, Japan, Russia, Brazil, and so on. So this is the world biocapacity which is represented here. So another very important thing to pay mind to here is that this is the world biocapacity, and this is the total ecological footprint which we have made. So as you can see, the our ecological footprint is growing over going over the world biocapacity. So this is not a good thing. This means that we've already the pace with which we are using natural resources, or the resources available to us on earth, the pace with which we are using it, it is all we have already gone over the biocapacity of our world. So what that means, uh, so sorry. So what that means is there is an overshoot. So we have already gone over the biocapacity of our earth. So as much as the earth, the at the rate we are using the resources is less than how much the earth can regenerate all the resources, or absorb in the waste which we have created. So that is not a good scenario. And then you can see uh, in either this document or the other document, uh, there are accounts. Okay, so this is the projection of how our rate of generating the ecological footprint is going to continue with different scenarios. So you must have heard of IPCC scenarios. So for all the scenarios, how the ecological footprint will be has been also generated as a graph in this. And I can find it. Okay. Among uh, maybe in this document or the other document which I have shared with you. One among the two documents will have an account of how to reduce our uh, ecological footprint on Earth. There would be a graph which will mention how, if you want to reduce our ecological footprint, what the scenario would look like. So this is the ecological footprint atlas, and again another. Okay, so going back to this, you can see these maps as well in the atlas. So while please share the link of ecological footprint. Okay, so Tara, I'll be sharing with you this presentation. So the link has been provided here in the slides. So you can just go to these links and you can just see the document for yourself. So there is the ecological footprint. Uh, the link for the ecological footprint atlas is in this slide, and then there is GFN Living Planet report. So link for that is here. So you can go on that link and you can see the Living Planet report as well. So so I think Professor, okay, see, this is the graph which I was talking about to you. So as I was saying, so there are scenarios which have been generated so that if we want to reduce our ecological footprint, uh, if we take the slow shift route, or we take the rapid reduction route, or we take moderate business as usual route, how our ecological footprint will be. So you can see that as well in this document. Uh, Also, I was showing you country-wise ecological footprint. So while it is very, you can see here, this document shows you country-wise ecological footprint and the variation in the ecological footprint from 1961 to 2005. It also shows the biocapacity. So you can see both in this. So the amount of biocapacity each country has, and then the amount of ecological footprint they are generating. So this is all well. However, one other key factor which we need to take into account is not just the ecological footprint of the country, but also after making that ecological footprint, what is the level of human development in that country, and that comes from this graph. So this graph, I think Professor Shivaji has discussed with you in very detail, and he has told you what each of these each of these numbers mean. What is the meaning if a country is located in an area which is within the biosphere's average capacity per person, but it's in a low development area, or about the countries like Qatar, I think he mentioned, which are having very high human development index, but then they lie in an area which exceeds the biosphere's average capacity per person. So they are high development, but the amount of biosphere's average uh, capacity they are using is not so good. So this, I think Professor Shivaji discussed with you in detail. So you can go to uh, this report, or you can even go back to the lecture and see what these are saying. Okay, so I hope it is clear to you now what ecological footprint is, and we saw for different countries which countries the largest the countries which have the largest ecological footprints. So I think you can answer this question very easily now, which is the country with the most significant ecological footprint. Moving on to the next question. So the next question is the sustainability perspectives are conventional economist, non-environmental degradation, integrational, yes, intergenerational, and what? So there are several types of, as I said, perspectives on sustainability. So you would have studied this Venn diagram. I think you already studied. We discussed it earlier as well. Of we discussed this diagram showing the intersection between the environmental, social, and economic aspects of sustainability. So, as I said, different practitioners from different fields and then academicians from different fields perceive our sustainability differently. So, for example, a conventional economist perspective on sustainability, as I told you, would be of a society or a particular practice or a population which follows practices which are sustainable in a way that over time, like presently also and even in the future, uh, the level of productivity which is there, so the economic output which is being produced can be sustained. So that is what sustainability is to a conventional economist. So that just focuses on economic aspects, although it has intersections with environmental aspects and social aspects as well. For example, for uh, some economic activity which is based on a natural resource like agriculture, there has to be natural resource available. So for example, there has to be arable land available, there has to be natural resources like water, sunlight, and uh, perfect climate conditions which are needed for that crop. All these natural elements of the environment also need to be in place for that economic activity to be sustained. So although the economic aspects focuses largely on the level of economic output that we are getting from it or the economic activity to be sustained over time, it cannot be seen in independence from the environmental aspects. However, in conventional economist sense, we can see sustainability perspective as sustaining an economic activity over time. Then there is a non-environmental degradation perspective. So, for example, I was talking about preserving economic environmental resources of an area. So, for example, we want to preserve biodiversity in an area, we preserve the natural resources, the natural forest resources, for example, in an area. But if we want to sustain that area over time, if we want to sustain the population which lives in that area, there has to be some economic output available to the population so that their life and their human development can be sustained over time. So otherwise, the population in that area will perish. It can you can think of it is in the terms of human population as well as in terms of the other ecological other population living in that ecosystem as well. So similarly for uh, non-environmental degradation perspective on sustainability, although although environmental aspects are a large part of it, it can't be studied as in its own, or it is always linked with economic and social aspects as well. So then comes the integrational ESE, which I have been talking about. So most researchers now think of all these three concepts in integration with each other. So as I said, although each of these three aspects are important in themselves, the way to actually achieve sustainability of any population, of any sustainable practice, is if you consider the three aspects in integration with each other. So ESE is environment, social and economic aspects. So that is what integrational ESE means. And then intergenerational. So while we are talking about all of these three aspects, another dimension which is added to this perspective is intergenerational. So this generation and the next and the next. So not only should these activities uh, be sustained till the time the present generation is there, but even for the generations which are going to come after the present generation is gone. So then the aspect of time comes into this place. So there are social, environmental and economic aspects, but when the dimension of time is added uh, uh, to this, then we go on to the intergenerational perspective. So this is an example. I have shared with you the link to this file as well. So uh, this is a journal article by Rodrigo Lozano. They have envisioned sustainability three-dimensionally. So all of the dimensions which we discussed here, and then also the time dimension. And this academician has discussed various types of integration and overlap of different aspects of sustainability, and with the time dimension as well, and then on various scales like local, national and global scales. So you can go through this document, see how further various aspects or perspectives of these overlaps or perspectives on sustainability can be, and can go through this document and see how all of these perspectives are explained. So coming back, so I think this is clear to you. So we discussed conventional economist perspective, non-environmental degradation of all of them, and then thinking of intergenerational. So another topic which another perspective which combines all of this holistically is the integrational and intergenerational. So it is both. It is not uh, intergenerational, just thinking of now or the future, or not just integrating all three aspects, but then thinking holistically about both. So it is the integration of all three aspects as well as the integration of now and for the next generation. So that is then again another perspective in which the sustainability perspectives are discussed in academia and practice. So I hope this is clear to you, and I hope you can now see what the answer to this question is. Moving on to the next question. So the next question is what are how many UN SDG goals are there? So this I discussed with you earlier also, that we started with the Brundtland Commission. So we defined sustainability with the Brundtland Commission, but after that several other reports came, and now all of that has been consolidated as United Nations Sustainable Development Goals, and we have a certain number of Sustainable Development Goals, which I have depicted here. This most of you, I think, you are familiar with, because you must have studied this in any subject related to sustainability, or you could have seen it in many other governmental or non-governmental initiatives which support sustainability as their goal. So these are the 17 Sustainable Development Goals, which is a list prepared by the United Nations. So can I have also provided a link which will take you to their website, and you can see the Sustainable Development Goals here. So you can see a detailed account of each Sustainable Development Goal. So you can either see all of them, see the report on a Sustainable Development Goal. So the United Nations, it publishes Sustainable Development Goals Progress Report annually. So you can see from 2016 there are annual reports. So you can click on and go on to see Sustainable Development Report for each year. You can download the report and then see what the progress that year has been. Apart from that, the United Nations also publishes a Global Sustainable Development Report every 4 years. So last was in 2023. Before that, the report was in 2019. So you can even to uh, go through that link to the global sustainable development report and check that. So this will be a comprehensive uh, report for all the combining all the sustainable development goals. Apart from that, what another thing you can do is you can go on to each sustainable development goal here, and you can go on to more info. So every goal has its separate targets and actions which are linked to it. So you can go on to more info, and so this is for example, this is poverty eradication, uh, or can for example even go to, let's go to this sustain SDG 11, which is make cities and settlements inclusive, safe, resilient, and sustainable. So this is another goal. So related topics to this can be disaster risk reduction, sustainable transport, sustainable cities, etc. And what you can do. So this is an overview presenting a general overview in infographic form of how of the Sustainable Development Goal and our progress in that. You can even go to the specific targets and indicators in each goal. So under the SDG 11, you will see what different targets are there. So for example, one of the targets is by 2030 to ensure access for all to adequate, safe and affordable housing and basic services and upgrade slums. So this is one target of SDG 11. And how do they see if the target is being achieved or not? So they see that, measure or evaluate that using some particular indicators. So for example, for this target 11.1, the indicator will be proportion of urban population living in slums, informal settlements or inadequate housing. So because we want to ensure access for all, so this proportion which is living in urban population, slum or informal settlement, or which has inadequate housing, should be 0. So by 2030, our target under this particular sustainable development goal is to reduce the proportion of this population which is living in slums, informal settlements and inadequate housing to 0. Similarly, there are other targets, and for each target there will be an indicator. So like this, you can go uh, peruse the different sustainable development goals and learn more about them. Uh, Coming back, so our question was how many uh, sustainable development goals we have. So I hope it is clear to you now how many sustainable development goals we have. Moving on to the next question, which is dash, which is blank for a city. So dash city leads the way on urban sustainability. So what we mean by urban sustainability? So urban means area which is urban, so city or town or uh, some kind of population, so some kind of area which houses urban population. So urban sustainability means sustainability for a city or an area which houses urban population. So urban sustainability, what it does, it specifically is that the idea of urban sustainability, it encourages revitalization and transition of urban areas or cities to improve the livability in the city, to promote innovation and reduce environmental impacts while maximizing economic and social benefits. So, as you know, urban areas are the concentration where all the economic and socio-cultural activities happens. So, while we want to focus on reducing environmental impacts and promoting innovation, which reduces the environmental impacts or uh, generate consumption patterns which are sustainable. We also have to focus on producing economic and social co-benefits along with reduction of environmental impacts in order to sustain the city. So, how do we measure urban sustainability? So we measure urban sustainability through sustainability city index. So Arcadis is the organization which has created this sustainable city index, and using that sustainable city index, it has measured the sustainability of various cities around the world over time. So I think when this was published, when these questions were published, it was for 2016 Sustainable City Index, but now they have their 2022 City Index made. So I've shared the link with you for both. You can go and view. I'm just showing you uh, the report here for the index. So you can go to their page and you can download the report for your own. So don't if uh, it's not working right now, so you can go through this link. You'll be asked to give your email ID and things, and if you just enter your email ID and your particulars, then you'll be able to download the report. I'll just show you the report which I have downloaded. Okay, I hope you can see. So this is the 2022 City Sustainability Index report. So uh, you can go and see their methodology of how they measure or what are the different indicators and things which they use to measure the sustainability of the city or to create their sustainability index. So this is the methodology. You can see the various metrics. So uh, how the metrics are created, how the score which is given to each metrics is generated, what are there. So this is a little bit of detail about their indicators. So they have three major pillars: planet pillar, people pillar, and profit pillar. So you might be able to see a little bit of similarity with the three aspects which we read about sustainability. So planet pillar, you can see it's similar to the environment aspects as we discussed. People pillar, it is similar to the social aspect which we discussed, and profit pillar is similar to the economic aspect of sustainability which we discussed. So you can see similar to the environmental, there is air pollution, bicycle infrastructure, energy consumption, renewable energy, environmental exposure, green spaces, greenhouse gas emissions, public policy, all of this under the planet pillar. Then people pillar, which we are considering similar to the social aspect. So quality of public transport infrastructure, things like education, health, life expectancy of people, then income inequality, work-life balance, all of such things are coming under the people pillar. And then the profit pillar, which we were considering as the economic aspect. So access to reliable electricity, affordability of things. So affordability comes with employment and how much income people are making, how the market forces are interacting, all of that. Connectivity, ease of doing business, economic development, employment, finance, all of those things. So these are the various indicator details which they have used in the 2022 sustainable city index. You can see here. So this, I think, okay, this is specifically for the profit pillar. Let's go further up. So this is the overall ranking which we are talking about in the question. So according to the sustainable city index, which are the most sustainable cities. So as you can see, even here, based on different indicators, or you can see the pillars of indicators which they have segregated, how each of the cities do. So according to the overall ranking, and first is Oslo, then Stockholm, Tokyo, Copenhagen, and all of that. And then how each city is doing with respect to specific uh, indicated pillars. They've also uh, created ranking based on specific pillars. So, for example, you can see for planet ranking how each of the cities are doing. Uh, then specifically for people pillar or the social aspect, as we are saying, how different cities are doing in the social aspect as well. And then uh, for the profit pillar as well. So another thing which you can do is go to the website and see. Another thing which you can do is go to their website and see information about specific pillars, or even for specific cities also. So you can find that information in the report, or you can even request for further information about a particular city if you want, through uh, the link which I showed you. So as when you go to download the report, when you click on to the link and submit your particulars, they'll also provide you with a further link from where you can access specific information about the sustainability in a particular city. So that also might prove useful to you if you want to study further about one particular city. We'll also see a little of the sustainability index in 2016, as I think this is the one which has been shared with you in the lectures. Okay. Okay, I think you can see it now. So this is the one which have been shared with you in the lecture. So this is index from 2016. Again, this has the similar pillars which are there in 2022, which is people, which I said, as I mentioned, social, planet, which is environmental, and profit, which is economic. And this is the ranking which they have provided. in the 2016 report. So on first is Zurich, second Singapore, third Stockholm, then Vienna, London, and so on. And then even here you can see the contribution of each pillar of sustainability. That. So I hope this is clear to you. Another thing which you can do here is you can compare a particular city and then you can see their progression over time in terms of sustainability. So you can see the progression for the whole index as well as each indicator head. If you would like to do that, if you would like to study the progression of sustainability in various cities, that also you can do, comparing the earlier and later results. Okay, coming back, I hope you can answer this question easily now. You just refer the sustainable city index and then you can answer which is the leading city in terms of urban sustainability. Coming to the next question, shifting to dash areas of high yield and low water stress, which will help us meet the sustainable target and meet the demand of feeding almost 10 billion people. Okay, so where do we shift? So the key thing which you need to see here is we are talking about feeding. So where does our food come from? Does it come from the habitat where we live in, or from the economic system, or from our ecosystem, or agriculture, which is a subset of the ecosystem, but still it is a very specific subset, uh, which is focused on producing food grains or food which we consume. So I think it is clear to you. And why it says high yield and low water stress? Because again, high yield and low water stress will mean that the area has more biocapacity. It can produce more output out of agriculture. Thus, it will be able to feed. Uh, it will be able to meet the demand of feeding larger amount of people. I hope it's clear. Coming on to the next question, uh, which is sustainable intelligent buildings as a complex system of fundamental interrelated issues of dash product processes and their interrelationship between them. So you are asked that what sustainable intelligent buildings are. So they have mentioned that they are a complex system of fundamental interrelated issues, product, process, and one more thing. So I think you have seen this diagram in your lectures. Uh, this again features the three aspects of sustainability which we mentioned, but apart from those three aspects, there are more components which are associated to sustainable intelligent buildings, and those components are people, processes, and products, which are mentioned in this. If you want to uh, get a better idea of what an intelligent building is, you can go to the work of Clements Kroon, uh, 2009. So how he defines intelligent building is basically an intelligent building is one that is responsive to the occupants' needs, satisfy the aim of an organization, and meets the long-term aspirations of the society. So occupant focuses on occupant, so the people, then is sustainable in terms of energy and water consumption and maintains a minimal impact to the environment in terms of emission and waste. So processes like the emission which it generates, or the waste it generates, or consumption which is done by the building, all these processes are also sustainable in nature. So the processes, and then healthy, the intelligent building is healthy in terms of well-being for the people living and working within them, that are functional according to the user needs. So functional, so you have to have some sort of functionality out of the building, so it is focusing on the products, but then again it's focusing on uh, well-being of the people associated with the building, so again focusing on the people aspect of the building as well. So I hope it is clear. You can even go further to the publication by Clements Kroon, which is Intelligent Buildings. And you can further see what he means by intelligent buildings, how he defines them, and what is the owner's perspective, what client perspective should be when investing in a intelligent building, what actually brings intelligence to buildings, and then again people, processes, and products. The integration of three components that also he has further discussed in this publication. And then I'll show you a snippet. He also explains the various terms which are related to sustainable intelligent buildings and cities. So you might have heard of various terms when we talk of sustainable and intelligent buildings and cities as well. For example, digital building, or digital cities, or intelligent cities, or intelligent buildings, as we are saying. Sentient even. So sentient is something related to sensory uh, awareness. So something which can have sensory awareness, which I don't think that buildings and cities are yet, although that is another term which has been used to define intelligence in buildings or cities or other systems. Then quality of life is another important term which comes when we talk about sustainability. So it focuses more on the uh, socioeconomic aspects, but again, it's a part of sustainability. Then things like livability. So livability comes with socioeconomic as well as in then green. So as you can see here, livability, social and environmental components both. Then green is largely focused on environment. So if you call a building green or a city green, it is focusing on the environmental concept only, not things like smart. So not on ICT, not on web or e-services or intelligence. Then nature. So if you call something to have natural or nature associated value, then again it is talking about the environment. So this is the classification of various terms when you talk about sustainable intelligent building cities. This again you can find in this publication by Kuhn. Uh, he has gone on in detail on this concept in the book. So if you want, you can have a look at the book and read further about it. Then again, one seminal this is one seminal work, but again more academicians often talk about energy efficiency when we talk about sustainable or intelligent buildings. So energy efficiency is not uh, a comprehensive doesn't give a comprehensive idea of if a building is sustainable or not, but it's uh, a very necessary steps in making a building sustainable. So if you see this way, a building can be classified into three types: energy efficient building, environmental friendly building, and then sustainable building. So energy efficient focuses on energy efficiency only, environmental friendly focuses on environmental aspects related to that building, and then sustainable building. So you can follow a methodology outlined by this author, and these are the steps which he asks you to follow to classify the building among these three types. So the first is to focus on the standard method of energy efficiency, which are economically feasible. Then focusing on the method of energy saving, which are beneficial to the environment as well. And then focusing on one which tries to bring about a equilibrium between the present energy need and the future energy needs, and then the environmental requirements which are associated with all of them, while also saving energy resources and keeping the environment clean for future generations. So all of the emissions and the waste which will be generated as a result of it, that is also taken care of. So you can go to this. So sorry, there is a problem with this link, so I'll make sure that it is sorted through before I share it with you. So I'll share a link to this document as well, where you can further read about sustainable and intelligent buildings. So I think it is clear to you now. So apart from these three aspects, these are the other three aspects which we study when we talk about sustainable and intelligent. So I hope answer to this question is clear to you. Then there is another concept which is called trias energetica. This again is a concept which is related to sustainability and intelligence, also energy efficiency in buildings. So it is a model which was developed by Delft University as a guideline for pursuing CO2 reduction in the construction sector, but after this it has been applied to the other sectors also. So it is mentioned as a three-step consecutive three-step process which can be employed by construction sector or other sectors for better energy use. So first of all is to minimize the demand. So minimize the demand means the minimization of the amount of energy which is required by the building to keep the building running. So it can be minimizing by better building design, so that the building doesn't so much energy in heating or ventilation of the building, or designing of building in a way that building also not only the building but the HVAC of the building in a way that the demand of the energy which is used to keep the building functioning is reduced. Then to use renewable resources. So as this you might all know that use of renewable resources over use of non-renewable resources is always better for the environment, as the resources which we are using they can be regenerated by the nature, or because we once we use them they either don't get exhausted, or even if they are getting exhausted, they the time for regeneration of the resources is less compared to the time that is taken by that is taken for regeneration of a non-renewable resource. And then the third step is efficient use. So we have minimized the demands, we have made sure that we are using renewable sources, but even after that we used innovative technologies or innovative building designs or innovative methods of use or innovative consumption techniques, so that our use of the energy in the building or in the city or whatever system we are studying is efficient. So this is the trias energetica concept, which is also related to sustainable, intelligent, and energy efficiency in the buildings. So I hope this also is clear. I have shared the link of this paper as well with you. So I think it was not showing. So this is the trias energetica concept which I have been explaining. And then this is the link. So if you click through to this link, you'll be taken to this paper. So this is the energy saving and efficiency trias analytica concept which has been explained in this paper. So you can go further and see the concept, and then how the concept has been detailed out for use. Okay. I hope it is clear to you now. So I hope this question is clear to you and you understand sustainable and intelligent things, or even sustainable cities or intelligent cities or system. Moving on to the next question, which is dash of the envelope is the first step to improve energy efficiency. So when we say envelope here, we are talking about the building envelope. So I hope you can understand very clearly seeing from this diagram what a building is. So the roof, the walls, windows, the foundation. So all of the physical barrier which protects the insides of the building from the outside environment that constitutes the building envelope. So how do we improve energy efficiency? Uh, how what do we do to the building envelope? As I said again, we have to protect the inside or the inside environment from the outside. So what do we do? Do we conduct? Do we insulate? Do we preserve? Do we restore? What do we do? This is the answer which you have to see. So here we are talking about energy efficiency. So why do we need energy and how does building envelope help? So imagine if it is very sunny, very hot outside, and you are inside the building, you will want the building to be cold. You want air conditioning, you want fans. So what it's doing? It's ventilating the building. So if it's very hot outside, you want ample windows, ample ventilation in the building. If it's humid or it's warm, not very hot. But if the temperatures are very high, like in a dry and arid desert region, you want the windows and doors to be small, you want the walls to be thick to insulate the inside environment from the outside. You don't want the heat from outside environment to come in. Similarly, if you are in a very cold environment, you want the insides of the building to be hotter so that uh, you can have a comfortable environment inside, and compared to the very cold weather or very cold temperatures which are outside, you want to be protected from the rain or other kind of precipitation and such things. So building envelope is the physical barrier between the exterior and interior environments, enclosing the structure. It is comprised of these components, as I told you, and internal environment is composed of the occupant, so the person living inside, and furnishing of building material. And to maintain appropriate climate or temperature or humidity conditions inside, we use HVAC, which is heating, ventilation, and air conditioning. So if we want energy efficiency while we use the HVAC system, so we want to insulate the building envelope. So for example, if we are in a cold climate, we want to heat the building from inside. But if the envelope is such that heat keeps escaping outside from the from inside of the building to outside, we'll need more energy to continuously heat the building. So then it won't be efficient. So we have to build our envelope in a way so that it insulates the inside environment and heat doesn't escape so easily. Similarly, if you are in a very hot environment, you want to have air conditioning, or you want to have cold air inside the buildings. Oh, but if the cold air keeps escaping and the heat from outside keeps coming inside the building, you'll need more energy to keep cooling the room. So again, there won't be energy efficiency. So in order to ensure energy efficiency, uh, air conditioning inside the building should be in a way, or the building envelope should be in a way that a lot of heat from outside the building doesn't come inside the building, so that the envelope is insulating the inside envelope. So I hope this is clear to you. You can even go to this source which explains the building envelope and a little further building envelope if you want to learn. So this, I hope it's clear to you now what of the envelope is the first step to improve energy efficiency. This is another diagram which Professor Shivaji would have discussed with you. So, for example, how so this I discussed with you what you need to do with the building envelope. However, this diagram discusses how you can do that with the building envelope, how you can use it efficiently to insulate the insides of the building or maintain the insides of the building at a temperature which is comfortable to the human body or which is appropriate for other components which are inside the building. So, for example, if you don't want a lot of heat from the sun to enter the building, you can have thermal barriers. So like this, so heat is coming here, but then because of the air, heat is not getting transferred. Air, which is a barrier, it's not getting transferred to the inside environments very easily. So the air barrier is there, or you can have efficient windows. So if as I mentioned, if you are living in a hot and humid area, you would want large open windows or large ventilation so that air can circulate through the building, and you can have uh, the humidity in the building is controlled because even from the components inside the building, so a lot of the electrical appliances, even the humans, they also produce heat and humidity. So in order to balance it out, you need proper ventilation. So it can be achieved through efficient windows or even through mechanical ventilation as is shown here. uh, then you can have duct sealing, and even consider these things for efficient lighting, which I missed so far. So we've been talking a lot about heat, but then lighting again is a very important aspect which we need to consider while discussing energy efficiency in building. So if you have ample amount of sunlight outside, you might not need so much lighting inside the building if you place your windows and openings to the building properly. So you place them in such a manner that they let in enough light inside the building so that you don't have to use a lot of artificial lighting, but have them be in a way that they also don't let a lot of heat from the sun inside the building. Another thing which you can do for efficiency in lighting is use innovative technologies like LEDs, which can reduce the amount of energy which is consumed for lighting the building. So these are the things which you can do with the example of things which you can do with the building envelope to have more energy efficiency. I hope this question is clear to you now very well, what the building envelope is and what things you can do to the building envelope to improve the energy efficiency. The last question for today's session is there are dash relationships between geometric shape and energy performance of the building. So is the relationship direct, is the relationship indirect, or is there no relation at all? So as you see, this diagram would have been discussed with you by Professor Shivaji, telling you so all these uh, shapes or geometrical shapes which are shown in the figure have the same volume, but they have different geometrical shapes, and the percentages which are written here uh, shows if you consider this cube as a basic case. So if you change the shape of the building from a cube like this, uh, how the energy use or the amount of energy the building will use, or the energy performance of the building will change. So if you change it, to a cylinder, the energy used by the building will reduce and come down to 98%. If you change it to a dome shape, it will come down to 96%. If you change it to pyramid, it will then further increase to 112%. Then if you break it down to two separate buildings of half the volume of this cube into two separate cuboids, then again the energy required to heat the building will increase by 133%. If you have it linear like this, it will be 142%. If you divide into 8 smaller cubes, the energy will increase by 200%. And so on. So as you can see from this example, there is a direct relationship between the geometrical shape and the amount of energy that is required to heat or cool the building in that shape. So this comes actually directly from the surface area of that geometrical shape. So the larger the surface area that is exposed to the external environment, the more amount of exchanges, heat exchanges through the surface will be there. So if you try calculating the surface area of each of these shapes, you will see the hemisphere and the cylinder have their surface areas which are lesser than the surface area of the cube. However, uh, uh, the surface area of this pyramid or two separate cuboids or one longer cuboid or 8 separate smaller cubes, their surface area would be larger than the surface area of this cube. So you can even say the relationship between the geometrical shape and the amount of energy required to heat or cool a building of that shape is directly proportional to the surface area of that shape which is exposed to the external. Uh, I'll show you one very similar example of vernacular architecture which uses this concept. So this is the Bunga houses of Rajasthan, as I mentioned. So the plan of these Bunga houses is circular. So their shape is cylindrical. So why this is done? Because in the Bunga houses are made in Rajasthan. The climate of Rajasthan is hot and arid, so there is a lot of heat which is transferred from the external environment to the internal environment of the building, which is not ideal. So, in order to reduce the amount of surface area of the building that is exposed to the external environment, they have made the plan of the building circular. So, circular when the plan of building is circular, the amount of area which is exposed to the external environment is the least. You can even do calculations of the surface area of a cuboid and a surface area of a cylinder and see for yourself if that is true or not. And so this is one very good example of use of this concept of vernacular architecture. So I hope it is clear to you what the relationship between the geometrical shape and energy performance of the building is, and can answer this question. So that is all for today's session. These are all the questions which I wanted to discuss with you. I think the questions which you are assigned this week are similar to this. If there are any more questions which you want to discuss, please go ahead. Tara, I hope you found the links in the presentation. The presentation will be shared with you via shared drive folder. So from the presentation you can find the link to all the journals and all the supplemental reports which I have shared in this presentation. If there are any more questions, please let me know, or else we can close the session for today. Quite a few people are attending. Nice to see you all. I hope you liked the session. No more questions? Yes, Arvind, please type your question in the message box. Nupur is asking, when will you get the PDF? Okay, I think that PDF will be shared with you directly from the NPTEL coordinators. So I will be sharing the PDF today itself with the NPTEL coordinators, and I think as they'll make it available to you as soon as possible. You can even go and check where you have the link to attend uh, these live sessions, because I remember earlier in last time's session there were links, yes, on the website itself. There were links shared for the shared drive folder and for the YouTube video which I'll be uploading. So all this session will be recorded, and the link for that recorded and then uploaded to YouTube, and the link for that YouTube video will be shared with you, and the link of a shared drive folder will be shared with you. So if you go to that drive folder, you can find the presentation which I shared with you today, and in that presentation you can find all the links of the supplemental material and the papers which I shared. I hope that is clear. Arvind, if you do you have a question? You've raised a hand. If anyone else has questions, meanwhile, you can also ask, while we wait for Arvind to finish typing. Okay, Arvind has asked regarding the Bhunga houses in Rajasthan. It is said that they are ideal for location with hot climates. Are there any instances of these sorts in the Himalayan and Ladakh regions of India? So, Bhunga houses are a form of vernacular architecture, Arvind. So, vernacular architecture is very specific to one area itself. So, there can be similar practices of vernacular architecture uh, native to Himalayan and Ladakh regions, but those practices would not be called Bhunga houses. They will have their own separate name based on uh, uh, based on the naming of the indigenous population which practices that particular vernacular architecture style there. I do not recall correctly what exactly the name of vernacular architecture practice in that region is, but I can get back to you on specific vernacular architecture of that area in the next session. Meanwhile, you can even go and look online of what their vernacular architectural practices are there. They will definitely focus on reducing uh, heat loss from within the building to outside the building. Apart from that, they'll also have other factors which they'll focus on. So protection from snow if it snows in the area. They'll have a specific type of roof systems for that. And then if they are constructed in an area which has a lot of seismic activity, they will focus on making which can withhold any seismic tremors or some other seasonal activity which is faced by the people. So, no, Hunga houses are very native to Rajasthan. They are a native practice of Rajasthan, but you'll definitely find other native vernacular architectural practices in the Himalaya. So I'll look up that and get back to you about that in the next session. You can also go ahead and read about it a bit, and ask any further questions if you have further questions in the next session. I hope that is clear. If anyone else has other questions, please go ahead. No more questions? Can we close the session for today then? Okay, people are leaving, so I get your message. Thank you all for attending today's session. I hope it was helpful to you, and I hope further sessions could also be helpful to you. If you still have, thank you so much. Thank you. If you still have any further questions which you need answered, there is always the forum. You can send your questions on the forum. Either me or Professor Shivaji or another teaching assistant can get to your questions, and it will either be answered to you via an email, or I can get to those questions the consecutive uh, in the next coming sessions. Thank you all for attending. Uh, have a good day. Thank you.